Hello everyone, I'm Prasad from Structural Guide. Today we are going to discuss about the spalling of concrete and how we can do the repair for such work. What is spalling? How it happens? How it can be avoided? And what are the things that we can do to minimize these kind of effects? And the repair methods. All those will be discussed today. Let's wait till the end of the video. You will be knowing a lot of facts on spalling of concrete. Let's see what is the spalling of concrete first of all. Now when it comes to a spalling, you can mostly observe this in the slabs and beams. At the bottom you have a reinforcement like this in the slab. So in a slab surface will be like this. You might have seen certain area of the concrete has been separated from the main structure, something like this. So if I draw this in another way, this is a reinforcement line, so bottom. So along the reinforcement, some certain part of the area the concrete has detached or separated or falls down. So this process is called the spalling, right? Let's see what will happen when it go on. But the process of this detachment of this concrete from the original concrete is the spalling of the concrete. This is what we call the spalling, right? Now let's see what are the main reason for the spalling of the concrete. Now the main cause of the spalling of concrete is the corrosion of the reinforcement. You know the reinforcement is the main element that carry the tension in the concrete, right? So you have a reinforcement like this and your concrete surface will be like this. Now what happened if corrode the reinforcement? Now during the corrosion of the reinforcement, rust is created around the reinforcement and the volume will be increased. Initially this volume increase will be 2 to 3 times, right? 2 to 3 times will be there, increase of the volume there. This area volume will be increased 2 to 3 times. With the time this can be raised to about 10 times, right? You can imagine what sort of a volume increase is there. So the volume will be increased in this area by 10 times from the initial volume. So there is a considerable pressure on this area. So with this pressure and the increase in volume create the detachment. So this reinforcement area, this volume will be increased. Then due to this stress on this concrete will be separated from the original concrete. That process is the spalling actually. So the main cause is for the spalling is the reinforcement corrosion. So we have to avoid this reinforcement corrosion to minimize the spalling of the concrete. So reinforcement corrosion, how this is occurred. So that is a very important factor. So there are many ways of occurring the reinforcement corrosion. One and most common way of occurring the corrosion of the reinforcement is the oxygen and the water react with the reinforcement. If in the presence of the oxygen and water or the moisture, reinforcement corrosion initiated. As you can see, not on the concrete, even if you put the reinforcement in the outside for the longer duration, it will definitely corrode. That's because in the environment you have the oxygen and the moisture. They are readily available. It is in the open air. So then the reinforcement or any steel element will be corroded. So the basic requirement is that. Other than that, there are some other ways or reasons for the corrosions that we will discuss later in this video, right? Now let's move on to the main causes of this corrosion. The first one we are going to discuss is the carbonation, right? You might have heard the carbonation, but let me explain this carbonation in detail. You know, your reinforcement, you will be having the reinforcement like this. I'm drawn now the vertical elements. This is the cover. So you are in the environment, we have a carbon dioxide, right? When carbon dioxide hit with the wind, on the reinforcement as on the concrete, it penetrate into the concrete like this. So carbon dioxide can penetrate into the concrete if the concrete have a adequate permeability and all that. This can happen, and also carbon dioxide react with the concrete. So I'm not going to discuss about the reaction and all that, then it will drag this video more and more, but you can refer any guideline on that. You can study the carbonation process. I'm just telling you the way of it happening and how it's connected with the spalling. So this process of carbon dioxide reacting with the concrete is called the carbonation. So this is called the carbonation front. This move toward the reinforcement gradually with the time. It's a slow process, but it happens. But for this speed, the properties of concrete affect to the speed of this process, right? Then when it comes to the reinforcement, the concrete and the concrete reaction naturally create a protective layer around the reinforcement. This is because of this alkalinity effect of the concrete. Now pH in this reinforcement area and the concrete will be in the range of 12 to 13, right? This is the usual pH value in normal concrete, but with this carbonation it attached to this protective coating, right? This protective coating will be attached because it won't allow the any penetration or any reaction with this protective coating or protective layer. Actually this is not an application, it's naturally created protection. So with this carbonation, this pH will be lowered to 8 to 9. So then the healthy environment for the corrosion will be created here. Okay, healthy environment for the corrosion, not for the protection but for the corrosion. A healthy environment for the corrosion will be that we say it healthy, but not for our benefit but for the corrosion. So when pH lower, it make easy for the corrosion process. Right, now you understood, I think it's clear to you now what carbonation does it. So with that, this corrosion process initiated. So with the corrosion, as I mentioned previously, the spalling will occur, and this volume increase and all that happens. Next one I am going to discuss, next reason is the low cover to the rainfall. Before that, I want to tell you one more thing. Now, in addition to the carbonation, there are other reasons for the corrosion of the reinforcement, that those also would create spalling of concrete. One of the main cause is that chemical attack. That chemical attacks in the sense, now chloride attack. Chloride, sulfate, sulfates are there in seawater and the environment. Also chloride there, when you build a structure close to the sea, you might get chloride. So chloride can easily penetrate like carbon dioxide into the concrete. Then it can reach to the reinforcement. It also create the corrosion of the reinforcement. Therefore, not only the carbonation but also other chemical attack also can cause the spalling of the concrete. That also there, especially chlorides, could create the spalling of the concrete. Right, now here I am going to emphasize one more thing. Now when the spalling or the corrosion happens, we might not notice. That's because now when you have a reinforcement like this, now as we discussed previously, this carbonation and all those will penetrate into the concrete. Even the oxygen and moisture and the oxygen will be there. So initially this corrosion happens around this reinforcement, but we might not notice because there may be hairline cracks in this area, but we might not notice until it falls down. So it is a very risky thing because we are not noticing the spalling or corrosion of the reinforcement. So it's very risky. But there are sometimes you might see there are some signs in elements, concrete elements in the surfaces. Now there is a movement of the brown color liquid like this. certain areas you might notice brown color liquid is along the surface, it's moving along the flow overlying surface. This is because when water penetrates into the concrete, if it is reinforcement or corroded inside, through these cracks, this water can go out. So this color, when it color, with the color, we can identify that reinforcement corrosion is there. In such situation, we should take immediate action and make sure this reinforcement corrosion is further not occurring. So we have to stop that, and you should make necessary actions to avoid further corrosion of the reinforcement. Other than that, it's very unlikely or very difficult to notice this corrosion of the reinforcement, because it is within the concrete and also it is inside, it's not visible to us. Therefore, it is very important to avoid this spalling or taking necessary action to avoid the spalling of the concrete. Right. Next, what I am going to discuss, expect to discuss, is the low cover to the reinforcement. What happens now? During the construction, we specify by the design, specify cover to the reinforcement. This is in the range of 25 to 30 millimeter usually. But during the construction, due to certain reason, this cover may not be there as expected. So low cover, as I mentioned previously, will help for the corrosion. So if you have a low cover, the penetration of the harmful chemicals, carbonation and all that will be very easy. With that, this spalling and the corrosion will be happen. Therefore, we have to make sure during the construction to provide the required cover, and especially when you do the inspection, we must have to make sure this cover is there. Therefore, that has to be handled during the construction very well, otherwise there will be issues like this. Right. Next thing I am going to discuss is the concrete grade. Right. This is also very important. Now, when it comes to the concrete, now you can see reinforcement here, the concrete grade. Now, what are the improvement with the concrete grade? Now, when the concrete grade is high, our cement content is high. When we have higher cement content, we have higher reactions. So this the concrete strength and the reactivity is very high. So we have a well reacted concrete and also very strong concrete there. More importantly, you have more strong concrete that have higher resistance to the penetration to the harmful chemicals. The penetration of the chloride or sulfate, carbonation will be resisted with the increase of the grade of the concrete or with the creation of the high resistive concrete. So that is there. So not only increasing the grade, but also we have to make sure the high resistivity and all that there. So with that, the resistance will be high, so it will be difficult to chemical to penetrate into the concrete. Right. Therefore, concrete grade also very important to us. Next, or the last course that we have to attend during the construction is the curing. So curing is a very important factor due to the two reasons. Let me draw the reinforcement bar and the concrete cover zone. So you have a reinforcement like this. So let's consider a slab. This is our cover zone. Right. What happens if you don't do the curing properly? First one. Now, when a concrete slab is poured, then when it let it dry, the water or the moisture in this area will be evaporated. Right? Moisture will be evaporated. Then what happens? The reaction between cement and the water. Right? Reactant cement between water and the cement create the concrete. So this is called hydration process. This hydration create the concrete. Now what happened is, now this water, if water is evaporated from the cover zone, then there won't be adequate water for this reaction. Then what happened is, now let's say your grade of the concrete is 25, you don't have adequate water there, then your grade will be lesser. So your grade will be reduced. That's because you don't have adequate water to complete that reaction. Therefore, it is very important when you have a slabs, concreting or like anything like that, do the curing properly. For thick elements, you have a different process. We are not going to discuss, but small elements or any element, whether thick or thin, we must avoid this evaporation of the water from the concrete surface. If it is evaporated, this will happen and your grade again will be lower. Then I discussed about the things that happen with the low grade concrete previously under the low grade concrete. So therefore we have to make sure the adequate water is there and curing process is done properly to make sure that adequate water is there to avoid the evaporation of the water. The second thing we are going to discuss is that with the high rate of evaporation of the concrete, shrinkage crack will appear in the concrete. So faster evaporation will create the shrinkage. You know, with the shrinkage, with the water evaporation, this volume will be reduced, then cracks will be forming. These cracks could penetrate even up to the reinforcement like this. Now, we discussed previously what if these chemicals and carbonation happens very fast. So, if we have a cracks, then the oxygen and moisture can penetrate into the reinforcement very easily because we have a part there, you have created part there. Then oxygen and the moisture can penetrate very easily into the reinforcement. Then corrosion can happen quite fast. So other chemicals like chloride can also be easily penetrate into the concrete very easily. If you have a chloride if you build a structure chloride environment, then corrosion will happen. Therefore we have to make sure curing properly to avoid these kind of situations in a structure. So it's now clear to you what are the main causes of the spalling of concrete and how we can avoid those, and what are the precautions that we should take to avoid the spalling of concrete. Next, we are going to discuss about the repair method. I'm not going to discuss in detail, but I will provide you an overview on repair method of the spalling of the concrete. Now, we have a concrete surface like this. Now, let's consider two reinforcement bars here for this example. So, what happened in the spalling? This area of the concrete will be detached from the main structure and fall down, so you can see the reinforcement and corroded reinforcement will be there. In addition to that, as I explained previously, this area might also be loosened due to the increase of the volume of the concrete, because now as we discussed at the initial stage before this spalling happens, this area volume will be increased, so this area will be loosened. So therefore this area should be look into when you do the repair work. So firstly you have to clean this spall or loosen concrete in this structure. Once you remove the loosened concrete, only you might be able to see the extent of the corrosion. So your reinforcement should have corroded significantly, or it might corroded up to a certain extent. So depending on the level of the corrosion, you have to decide whether to replace the reinforcement or add the reinforcement together. So if the reinforcement is extensively corroded, you might remove this reinforcement and you can add the additional reinforcement or new reinforcement bar. You have to keep in mind that when you do this kind of a repair, you must have a support. Now if you removing one reinforcement bar in slab won't make issues, but if you are going to remove certain number of reinforcement, few reinforcement bars, you must support the slab before doing this repair, because if you don't know the condition of the slab. So if other areas also have significant damages, removing this chipping, all those could vibrate the structure, and even if it is all the area, if it's damaged, then even it can collapse. Therefore you have to make sure adequate support is there when you doing the repair, especially if you have a large area that is corroded with this effect. Right, now we can do two things. One thing is you can replace the reinforcement bar. If not, you can add the additional reinforcement bar and it can weld with the same reinforcement bar. It's like this. You say this length is corroded, so what you can do is you can add the reinforcement bar. So this is the existing bar like this, so you can lap with the additional reinforcement bar. If not, you have a reinforcement like this, so it's extensively corroded, you can lap additional bar like this. Usually we can do the welding here to make sure the proper bonding there. So generally we keep 10 times D for the welding. This is general norm, but you have to make sure adequate welding length is there. This will vary, maybe 10, maybe 20 times. So that has to be considered depending on the condition of the concrete and their requirement. So this is the general value. So we have to lap the reinforcement like this. During the welding, you have to make sure the reinforcement are not damaged. A qualified welder shall be used for these kind of purposes. Right, now your reinforcement replacement and cleaning is done. So as I think I could forget to tell you, when you clean this reinforcement, you have to clean extensively. Otherwise, if you keep the rough, there will be debonding. Therefore, you have to make sure properly cleaning happen in the reinforcement. So once you clean the reinforcement, you can apply anti-corrosive for the reinforcement. Then it will avoid further corrosions. But before applying anti-corrosive, you have to make sure 100% cleaning is there. Right. Now once you clean the reinforcement, your strengthening process is almost complete. Now what you have to do is you have to do the concreting. So before doing the concreting, you have to create this bond properly. Okay, you have a new concrete and old concrete, so you have to make sure this bond is proper. Right, what we can do is you can apply bonding agent there before concrete is applied. So you can make sure bonding agent is there. So you apply bonding agent for the new and old concrete to bond together. So this application shall be done as specified by the supplier. So you can follow these guidelines specified by supplier. So then according to that, this application shall be done. Right. Next thing is the concreting. What sort of a concrete you can put it in there. So usually this kind of a situation, these slabs of it, you can't put usual concrete, normal concrete. That's because when you pour the concrete and when it hardens, its volume reduce. Concrete get shrink with the hardening. So it will be like this because its volume will be reduced. There will be a gap here. So what happens if there is a gap? There is no attachment between existing and the old concrete. There will be a gap. Then similar situation as happened previously would happen there also. Therefore, you have to use special concrete, that is non-shrink concrete. You have to use there, non-shrink. You might know this non-shrink concrete. You can use non-shrink concrete. What is as name implies, this reduction in the volume will be very minimal. So when you have a non-shrink concrete, the bonding will happen here as well because its volume reduction is minimal. Therefore, there won't be, we expect there won't be any gap between existing concrete and the new concrete. So we have to keep in mind non-shrink concrete is used for this kind of a repair, and this mixing and applying water and curing of non-shrink concrete shall be done as issued by the supplier, because we have to follow the supplier specification in these kind of situations and general construction practices. By following that, you shall do the concreting or concrete repair work here. Right. With that, I think we have discussed almost all the things connected with the spalling of concrete and its repair work. Today we will discuss about the spalling, how it happens, how it avoided, and how it can be repaired. I think this video is very useful to you. We hope to share similar kind of a knowledge with you. Let's meet again from another video. Thank you very much for watching our videos.